Okay, let's look at the swimmer's problem. Right, so here's the situation. So here's the river, and the swimmer is trying to swim straight to the right from one end of the river to the other end. Right? Then the current, the velocity of the current is given by this equation. V sub r is equal to V0 times quantity 1 minus x squared over a squared. Right? So this means that the current in the middle of the river is the fastest, which is V0, and then it kind of slows down as you go toward the shore. Right? Alright, so let's try to do that. So, we want to find the path of the swimmer. And as you can expect, first you can go almost sideways, but as you get closer to the middle of the river, the current gets faster. So what happens to the swimmer's path is that it's going to actually start drifting. And it's going to have the most drift in the middle of the river, and the current gets slower, then you can get to the other side. So the swimmer's path is going to have this curve, right? And what we want to do is we want to find the equation for this swimmer's path, right? So let's do that. All right, first we have to interpret a Vs. So Vs is the sideways, so it's the horizontal component of the swimmer's path. So we can think of let's say dx over dt is basically the swimmer's the velocity of the swimmer, v sub s, right? And also if you're looking at just the current, this is the vertical component of the swimmer's path. So you can think of dy over dt, which is going to give you v sub r, right? So if you want to set up a differential equation for dy over dt, dy over dx. So that way we can express y in terms of x. Alright. Then this is equivalent to dx over dt over dy over dt over dx over dt, which is going to be, alright, so this is the same thing as VR, and the dx over dt is same as ds. So the equation can be written as, since the VR is written this way, so V0 over Vs times quantity 1 minus x squared over a squared. Right, so this is the differential equation. Right, so let's do a little bit more concrete example where a is 0.5 miles and v0 is 9 miles per hour and v sub s is 3 miles per hour. Right, so this is a differential equation. So dy over dx is equal to v0 is 9 divided by vs is 3 times 1 minus x squared over, right, so 0.5 is same thing as 1/2, right, so it's going to be 1/2 squared, so 1/2 squared, right? So we can clean it up a little bit. So you have a 9 and 3 cancel out, so you have 3, right? And this is 1/4. Dividing by 1/4 is multiplying by 4. So this is going to give you 3 times quantity 1 minus 4x squared. Right? This is actually a fairly easy differential equation to solve. all you really have to do is to find y, we just need to simply take an antiderivative. So you have a 3 1 minus 4x cubed x squared with respect to x, right? Which is going to give you 3 times antiderivative of 1 would be x. Antiderivative of negative 4x squared would be x cubed over 3 times negative 4, right? Plus some constant c, right? Then we can simplify, so you distribute 3, so you're going to get the 3x, and the 3 and 3 cancel out, so it's negative 4x cubed plus some constant c, right? Then we need to find the initial condition to find the value of c, right? Since the swimmer is starting from this point right here, which tells you that, let's see, initial condition would be y of negative, maybe I should say up here, so y of negative 1/2 would be 0, right? Let's use that initial condition to find the value of c, right? So plug in negative 1/2 into here, so it's going to be negative 3/2 minus 4 times, let's see, negative 1/2 cubed is negative 1/8. So you're, let's say, subtracting, let's see, negative 4 times negative 1/8 is adding 1/2, right? 4 and 8 cancel out, and plus c, which is going to be simply negative 1 plus c. And this is supposed to be 0, right? So therefore, c is equal to 1 by adding 1 to both sides, right? Therefore, we could find the swimmer's path, which is y equals 3x minus 4x cubed plus c, which turns out to be 1, right? So this is the equation for the swimmer's path. Alright, that's it. I hope that this was clear.